So with the distributed pumping, basically you're taking anything that was a control valve and replacing it with a smart pump, an ECM pump.
Okay.
And you can do that and leave the existing control system in place.
Okay.
So literally that control system can just send that signal to the pump instead of the control valve. So it's just ramping a pump up and down rather than opening and closing the control zone. And then it has, like the Magnet 3 specifically has a flow limit feature in it. So if you say, I want to flow no more than 7 GPM or 2.5 GPM, whatever it is, through this fan coil unit, then it will limit it so you don't have to have the flow control valve as well.
So then does it do a minimum and maximum and then like a 4 to 20 like linear regression to figure out, where you're at, or is it precise enough to sit there and you're calculating off leaving air temperature?
So yes to all of it, potentially. Depends on how you want to do it. So it does have a minimum speed, and it would be enabled and disabled by either the control system or that unit. If it's that unit's running and it needs water, it would enable the pump and then it would run. So you can either have that external control signal from building automation that's looking at the external or the air temperature, and it can send that 4 to 20 or 0 to 10 signal and ramp it up and down, or it has built-in differential pressure and temperature transmitters in it, so you could look at the or you can bring in an external sensor for temperature. So if you wanted to look at leaving air temperature or leaving water temperature, you could index against those, and it can control to that. So there's a lot of different ways that you can do that. You can also, like on a fan coil, you could also do it on differential pressure, proportional pressure, any of those control modes all built in to it. But the simplest way to do it is literally leave the control system as it is and just have it control the pump instead of a valve. And so what that does, it does a couple of things. One is now you're distributing out the load of the pumping to all of these smaller pumps. So your primary pumps can become much smaller.
You would take the coil drop out of the primary pump. You would take that run,
the return pipe,
return pipe. Okay. But with this primary system, for lack of a better word, with this primary piping system kind of behave more like a reservoir? Like, would it be smarter to make it flow slower and a little, like, not reduce the pipe size? And really what you're using the VFD for is just like a final tuning of the system. And then you have all these quick hits off these little pumps kind of behaving.
Sure. So you're going to have a bypass,
of course,
in the in the plant from the supply to the return, and that's where the excess is going to return. And so there's kind of two different parts of control, right? Like, so all the distributed pumps can do just what we said, and then you could take the existing primary pumps and just ramp them down, right? Or you can replace the existing primary controls with, like for this instance, the Grumpfoss controller. And what it does is it looks at first differential across the chiller to make sure we're satisfying minimum flow across the chiller. And then as long as that's satisfied, then it starts to look at 4 temperature sensors on the bypass. Okay, before and after the bypass on both the supply and the return. And basically looking at those, it can know if the system is balanced or if the supply is bleeding to the return or if the return is bleeding to the supply. And depending on which of those is happening, it's going to ramp the pumps up and down. Right? So if the supply is bleeding into the return, then we can slow the pumps down to balance it back out. If the return's bleeding into the supply, then we need to ramp the pumps up, the primary pumps up. And so what they've seen in the trials on this is that just replacing the control valves with the smart pumps, they slowed down the primary pumps, but it was still the same primary pumps they had, was, I think it was 32% energy savings. And then they estimated over 50% when they would switch the primary pumps to this control